Guys, Mr. Scrayback here. Wanted to welcome back you all to Fundamentals of Chemistry. Um, and the goal for these next series of lessons for myself and Miss Bertolacini is that we are going to be kind of going over the basics and the most important skills we think you guys need coming into the fall next year. So we really thought the best place to start off was kind of to go back to this build an atom simulation that we had done a while back, and go over those basic pieces of an atom and the charges. Just get a general refresher of where we left off, because those are going to be so important as we kind of get into some of the new things. So when you go to your Google Classroom, you're going to see a link to this PhET simulation here, the Build an Atom simulation, and this should look familiar to you. You can do this on your phone, you can do this on a tablet, you can do this on a laptop. And then there's also this assignment that you're going to be filling in on Google Docs. I'm going to show you guys how to do some of these in this video. So the first thing that you're going to want to do is have all three of these tabs open. The presentation, so you can kind of follow along, the Build an Atom here, and then this assignment as well. So when you click play, you're going to get that simulation up again. And you can see there's a game where you can do some practice that kind of goes over how to use those elemental symbols that you see on the periodic table, as well as that build an atom piece that you guys should be pretty familiar with. And we're going to kind of go over all these basics. So looking at where we left off, we were talking about patterns that we see in the periodic table. We spent a lot of time talking about these numbers up here and what do they mean, and these numbers down here and what do they mean. And we're going to kind of get back into that just so you guys can get that refresher and go, oh yeah, that's where I remember all that stuff now. So first off, let's go over atomic structure. So when we look at the atomic structure of an atom, there are protons and neutrons, and those are in that center point. They are the nucleus of the atom. And protons are what are going to be defining that element. Protons are the element. If you have 6 protons, you're carbon. If you have 5 protons, you're not carbon. If you have 7 protons, you are not carbon. In order to be carbon, you need to have 6 protons. It doesn't matter how many electrons you have, or how many neutrons you have, or how many of those you have combined together. As long as you have 6 protons, you are carbon, period. You could have a billion neutrons. You're going to have some other problems then, but you could have a billion neutrons and 6 protons, you would still be carbon. So when we talk about what an element is, it all comes down to what is going on in here, and specifically what is going on with these positively charged particles that we call protons. Speaking of charges, just a quick refresher, remember that protons are positive, neutrons are neutral, they have no charge. So if you're adding neutrons, that's not going to change the charge of an element. If you're adding electrons, that is going to change. If you're taking away electrons, that is going to change the charge of an atom. However, if you're adding protons, yeah, that might change the charge, but it's also going to change the atom itself. So if you go to that build an atom, and let's say I have helium here. So right now this is a positive ion of helium because I have 2 positive charges and no negative charges. If I throw in 2 negative charges, you can see it changes to a neutral atom. And then if you click on this box here, that net charge, you can see neutral. I have 2 positives, I have 2 negatives. These are canceling each other out. But if I take away a proton, look, it's no longer helium, it's turned into hydrogen, and it's no longer neutral, it's hydrogen with a -1 charge. I've changed the element by changing the number of protons in the nucleus, and I've changed the charge from neutral to negative because now I have a different number of protons and electrons. The two are not equal. So therefore, it has to have either a positive or a negative charge if the number of protons and electrons are not even. So that's really important that you guys have that down. Moving on to the next thing that we were talking about before you guys left was calculating the number of neutrons in a atom and its overall atomic mass. So when we look at the number of neutrons and atomic mass, those two things are related to one another because the atomic mass is the total number of particles in an atom's nucleus. In other words, it's the protons plus the neutrons. Electrons don't affect mass. They're too small. They're too tiny of a particle. They effectively have a mass of 0. So we can test that here in the build an atom, right? So if I now open up the mass number, you can see the mass number is 1 because there's 1 particle in the nucleus. Let's go ahead and make that neutral so we know it's neutral. So if I add a neutron here, mass number's jumped up to 2. Because I have 2 particles inside the nucleus. As I look at an element on the periodic table, like let's take sodium for instance. Sodium has 11 protons. That's that number up there. Okay. And its atomic mass, or its atomic weight, sometimes it's even called molar mass, is that bottom number down here. Now remember, we're always rounding that to the nearest whole number, so you can see in the steps to calculate the number of neutrons, I've said this is 23 particles because I'm rounding that 22.99 to 23. So sodium has 23 particles in the nucleus, and if I know the number of protons, and I know that there's 23 particles total, well, 23 particles minus the 11 that are protons gives me 12 neutrons overall. And if I have 12 neutrons overall, that is going to add up to 23 particles in that nucleus. So that's how you calculate that atomic mass. Okay. The other thing we were talking about were energy levels. So remember that the energy levels are the number of orbitals. Sometimes we've been calling them rings, but really they're called orbitals surrounding an atom. And we can find this using the period number of the periodic table. So here we have the periodic table. Okay, and by the way, this periodic table was taken from this link down here. So this is a link that's in the presentation. So if you click it, it's going to bring you right to where I took a screenshot of this. But what's neat about this website is that it's an interactive periodic table. So if I hover over something, it's going to pop up in this spot right here, whichever element I'm looking at specifically. So before we're looking at sodium, so you can see sodium has the same information that I had before. Some of the numbers are a little bit different. Pay attention to those 3 little numbers in a column in the top corner. So if I actually click on sodium for a second, it's going to give me a whole bunch of interesting information about sodium specifically. I don't necessarily care about that right now. What I want are just the periodic table. So I'm going to go back to the periodic table. And if you see that 281 in the sodium box there, we're going to talk about that in just a second. Remember that we talked about how electrons are organized for an element. So if I come back, you'll see that these have all of their electrons laid out in a specific pattern. So for sodium, the layout is 2 electrons in the first shell, 8 electrons in the second shell, and then 1 in the outermost shell. And Bohr models are used to show the nucleus with all the energy levels and the electrons in each energy level. And it is assumed that these are neutral atoms. And remember, we talked about in order to have a neutral atom, if we go back to this for a second, in order to have a neutral charge, you have to have an equal number of protons and electrons. So this hydrogen atom is neutral because protons and electrons are equal. So looking at this, how do I know sodium had 11 electrons total? Well, I know that because it had 11 protons. So I'm assuming the sodium is neutral because all atoms really want to be neutral. And that's going to be important when we come back to that later. So here, chlorine has 17 protons in the nucleus, and chlorine has 2 in the first shell, 8 in the second shell, and then it has 7 in that outermost shell. So all these rings, the thing that both sodium and chlorine have in common, so you can see element 11 and element 17, the thing that these two elements have in common is that they are on the third period or row of the periodic table. And because they're on the third period, they have 3 energy levels. So how do you tell how many energy levels something has? You look at which of these periods or rows the element is found in. So hydrogen has 1 ring, helium has 1 ring. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, these all have 2 rings because they are in period 2. That's one of the ways in which the periodic table is organized. So that's how you know how many rings an element has or how many orbitals an element has. The other thing we talked about before we left was valence electrons, and this is really important. Okay, valence electrons is basically what we're going to be talking about in these next 3 or 4 lessons. This is going to come up over and over and over again. So valence electrons are the electrons that exist in the outermost energy level or orbital or shell or ring. Those are all kind of interchangeable in the chemistry world. And you can see sodium, for instance, only has 1 valence electron. There's 11 electrons total, but there's only 1 in the outermost shell. Chlorine has 17 electrons total, but there's only these 7 in the outermost shell. So we chemists are most concerned with these electrons, the ones that exist in that outermost shell, because they are the ones that allow elements to bond together. So when we talk about hydrogen and oxygen forming water, well, that interaction of H2O all comes from those outermost electrons. So the way that we chemists show that is we use what we call those Lewis dot structures. Lewis dot structures show the outermost electrons of an element, and they help to quickly identify ions that elements might form in order to bond together. So for sodium, remember it has that 1 dot. Chlorine, on the other hand, has 7 dots. And when I make a video to show you guys how to do some sample problems, I will remind you how to draw those Lewis dots. So the last piece of information you need to know for those valence electrons is how do we figure those out? How do we quickly identify what the valence electrons are? Well, you could do a Bohr model for every single element every single time you want to know, oh, okay, it's 7 electrons or 17 electrons, so I got to do 2 and then 8 and then this many. Or you could just take a look at the group number or the column number. So remember we talked about these top numbers indicate valence electrons. So if you are in column 1, you have 1 valence electron. Sodium, for instance, is in group 1 or column 1, so it has 1 valence electron in its outermost shell. All of these elements have 2. So beryllium, magnesium, calcium, all of those have 2 electrons in their outermost shell. Columns 3 through 12, or groups 3 through 12, we're not really going to spend a lot of time on worrying about those for fundamentals of chemistry, especially now that we're trying to kind of get down to the most crucial points. So don't worry about 3 through 12. What I want you to remember is that we're skipping these, and that as soon as we get to group 13, in group 13, we start to see 3 valence electrons. So boron, aluminum, gallium, okay, these all have 3 valence electrons. 14 has 4, 15 has 5, 16, 6, 17, 7, 18, 8. The only exception for group 18 is helium. Helium only has the 2 valence electrons because it is in that first row or period. So it only has the 1 ring, so it can only hold 2 electrons at all because its rings are too small. It doesn't have the space. So that's how you quickly identify valence electrons, is you look at this top number here. So you might be thinking like, okay, this is all, I remember this now. The thing we were kind of talking about is the formation of ions, like right before we left. And this formation of ions is that ability for an atom to either gain or lose electrons in order for it to no longer be neutral. So we kind of talked about this a little bit previously, but this lithium atom here has 3 positives and 3 negatives. So therefore it's neutral. It's got 3 protons here and 3 electrons here. 1 is in the outermost shell. Lithium over here, however, has lost that outermost electron. Valence electrons for positive forming elements like lithium, well, they don't stick to the element very well. They're very easily taken away, or they're very easily sent off somewhere else. And when that happens, that lithium ion is going to form a positive 1 charge. Because now we have 3 positives, 1, 2, 3 in the nucleus here, and only 2 negatives to cancel out. So overall, the net charge is +1. Sometimes you'll see this number here referred to as an oxidation number. It's just a fancy way of saying what is the atom's charge. So when we look at this boron, for instance, okay, see if you can take a second and think, okay, what would be the charge on this boron atom if we are looking at the number of protons that we see and the number of electrons that we see? So the answer to that would be, just move it up there, +3. Because we have 3 more positive charges than negative charges. So therefore, there is a +3 charge on boron. So to do this assignment, right, on Google Classroom, you will see this document, the Build an Atom Refresher, to get a chance to kind of play around with some things and get back into it a little bit, identifying all of this crucial information. And I am going to put on the very last slide of this presentation here, so it's blank right now, but I'm actually going to do a separate video that shows you exactly how to do helium and fluorine, and hopefully you'll be able to use those to complete the rest of this table. And then once you have this table done, you can start looking for patterns, right? Science is all about finding those patterns and developing models with those patterns. So you are going to go ahead and answer those, and you can type right into the response box. And everyone is going to get their own document for this piece on Google Classroom. So it'll say your last name, Build an Atom Refresher. Okay? So I will see you in the last video here, and stay healthy, stay safe, and I hope to see you guys sooner rather than later.